Hello guys, so today we are going to solve an interesting diophantine equation which is also replica of the USA IMO team selection set. So basically the idea of to solve this equation, this diophantine equation is to assume that n is greater than or equal to 7. So if n is greater than equal to 7, then n factorial will definitely be divisible by 7, which means that 7 divides 4 raised to b plus 11 raised to c. Therefore, 7 divides 4 raised to b plus 4 raised to c. Now, we know that 64 is equal to 63 is divisible by 7. So, 4 cube is equal to 1 mod 7, which means that 4 raised to 3k is equal to 1 mod 7, which means that 4 raised to 3k plus 1 is equal to 4 mod 7, and 4 raised to 3k plus 2 is equal to 2 mod 7. So 4 raised to b is equal to minus 4 raised to c mod 7. Therefore, 4 raised to b minus c is equal to minus 1 mod 7. Therefore, 4 raised to b minus c is equal to 6 mod 7. But this leads to contradiction as 1, 4, 2 are the only possible remainders left by a power of 4 on dividing by 7, which means that n is less than or equal to 6. We also know that 7 raised to a plus 4 raised to b plus 11 raised to c is greater than 22, as a, b, c are natural numbers. So greater than 7 plus 4 plus 11, which is greater than 22. Therefore, n factorial will be greater than 22, which means 3 divides n factorial, which means 3 divides 7 raised to a plus 4 raised to b plus 11 raised to c. We know that 7 is equal to 1 mod 3 there, and 4 is equal to 1 mod 3. Therefore, 11 raised to c is equal to 1 mod 3, which means that minus 1 raised to c is equal to 1 mod 3, which means that c will be even. So let's assume that c is equal to 2 into something. Let's assume it is k. So let's c is equal to 2k, which means that n factorial is equal to 7 raised to a plus 4 raised to b plus 121 raised to k greater than 132, as 7 plus 4 plus 121 is 732. So n was clearly great. N factorial will be greater than 30. N factorial will be greater than 132, meaning that n will be greater than equal to 6, which means, but you also know that, and we have already computed that n is less than equal to 6, which means that, and we have found now also that n is greater than equal to 6, which means that n has to be equal to 6. Therefore, 7 raised to a plus 4 raised to b plus 121 raised to k is equal to 6 factorial is equal to 720. If we assume that k is greater than equal to 2, then 7 raised to a plus 4 raised to b will be less than 0, which is a contradiction, which means that k is less than 2, implying that k is equal to 1. Therefore, 7 raised to a plus 4 raised to b is equal to 599. We know that 599 is equal to 4 mod 7, because on division by 7, it will be 7 into 85 plus 4. Therefore, 4 raised to b has to be 4 mod 7. And we have calculated earlier that 4 raised to 3k plus 1 is equal to 4 mod 7, which means that b has to be 3k plus 1 to get to leave a remainder of 4 on division by 7. If b greater than equal to 5, then 7 raised to a will be less than 0, which is again a contradiction. Therefore, b is equal to 1 or 4. If b is equal to 1, then 7 raised to a is equal to 595, which is a contradiction. Therefore, b is equal to 4, meaning that 7 raised to a is equal to 343. Therefore, a is equal to 3. Therefore, the only solution to this diophantine equation is 3426. Thank you for watching the video. Hit the subscribe button